Hello and welcome. This is a follow-up on my previous video on the AxxSolder, an open-source JBC style soldering station. In this video we'll keep testing the AxxSolder and then I'm gonna compare it with my £500, about $700 genuine JBC soldering station. We're gonna try and solder the impossible and see how good the AxxSolder is at dumping power into the soldering tip. Now in the previous video we assembled the AxxSolder, we turned it on, we programmed it, and everything went pretty well. At the end of the video I tested for what I really feel it's important in a soldering station. I checked for a voltage leakage and current leakage. And the AxxSolder was my very first switch-in mode power supply driven soldering station which didn't exhibit any voltage or any current leakage at the tip. That was really impressive. And at the end of the video I will be able to share my opinion on the AxxSolder because I've been using it with my JBC soldering station for a few weeks now, so I now have a pretty good idea on whether I'm happy to recommend it or not. So let me thank today's sponsor PCBWay and let's continue testing the AxxSolder. The AxxSolder can be powered from USB-C, it's got power delivery, so I believe it goes up to 20 volts, and I'm using my Lenovo charger or power supply, if you want to call it that way. I think it's like a very good quality USB-C power supply. This is only rated 65 watts, so let's see what it does. Turn it on, 3, 2, 1, go. And it's working, I'm reading, 19 volts, 20 actually, 20, yes, of course, it's going up to 20. And I see a limit of 65 watts, which is exactly what the power supply is doing. So this is pretty impressive. Let's turn this on. Yeah, it's going up to 65 watts. Now, do I read a voltage at the tip? Yeah, I do read something. I got like 5, 6 volts in DC. And in AC, obviously, it's going to be jumping all over the place. Now it's stopped, so let me turn up the temperature a bit. Yeah, it's more or less the same. I guess we would need an oscilloscope to see what kind of voltage we have. What matters is whether we have current or not. I might expect a little bit, but let's see what we're reading. I'm in current mode and I'm really not reading anything in AC mode, so that's great. The soldering iron is running more or less steady at 19 watts, so if there was something, I would be able to read something. What about DC mode? Nothing in DC mode. Fantastic. That's a very good start. Let's try with the speaker. You know how much I like that test. And there is definitely something coming from the speaker, though, once again, if I'm not reading anything with my multimeter, I guess that's probably nothing to be worried about. Though, once again, it's not ideal. You know how much I don't like soldering irons which are leaking current. I don't care how little that is. To me, that is unacceptable. But this is on USB power. It's kind of unavoidable. If you don't want this, you just plug it through the recommended power supply, and this problem doesn't exist. Let's see if the Kaiwitz can read anything in microamp or whatever it's reading. Just turn this on. Yes, we have 0.3. It's the same 0.3 milliamps we were reading before in AC and more or less nothing in DC. So definitely there, definitely not what I like from my soldering iron, but that's only on USB power. I would say this is probably totally safe. No, so far so good. But then I went to test a different USB power supply. Here on my desk I have a U-Green 200 watts power supply, and when I went to test the AxxSolder with that one, well, the result literally shocked me. This USB-C cable comes from the U-Green. The cable itself is limited to 65 watts, so I'm not really expecting more than that. Everything works. Yes, the AxxSolder is limiting itself to 60 watts, but when I went to measure the current, if I turn this on, oh, it even switched off. I don't know if you saw it. There was a spark on my soldering tip. Let me see if I can show you. I need to turn the lights down and try and capture that because it's fun, but it's not fun. I mean, this is pretty dangerous, I'd say. Now, this is dangerous. I wasn't expecting that. Now, what kind of current am I reading when I'm doing this? Well, my fluke goes up to 2, but I'd imagine it's even more than that. And I'd imagine with an oscilloscope I would be able to see much higher numbers. But 2 amps at, what's that, 20 volts? Actually, what kind of voltage am I reading here? I'm not reading match, to be honest. I'm reading 1.5 volts DC and the same voltage in AC. So we're not talking about 20 volts, of course. But 2 amps, whatever voltage that is completely unacceptable. Now, as you can imagine, I've been in touch with Axel, and we've been looking on why this only happens with the U-green. And it turns out that the U-green is the only power supply which is shielding the shell of the USB-C connector. You're reading 3 ohms because I'm getting ground from a different place in my desk, and I'd imagine by the time it goes around my desk and back into the U-green, we've got a few ohms of extra resistance. But if I check the Lenovo power supply, you can see that the shell of the USB-C is not directly grounded. There is a 1 mega ohm resistor somehow. And if I'm checking with this standard Apple power supply, well, this doesn't even have a 1 mega ohm resistor. It's nothing. It's not connected to ground at all. And to be honest, I've looked into grounded power supplies before, and none of the power supplies I've ever tested myself, they were ever grounded. I didn't know you could actually have ground on the shell of the USB. So I'm not entirely sure how to read this, because the AxxSolder works perfectly fine with this power supply, it works perfectly fine with this power supply, but it massively misbehaves with the U-green power supply. This is a secure S99 soldering iron I reviewed some time ago. I don't really use it very often, but I do remember it was working pretty well with the Lenovo power supply. Oh yeah, look at that. This is it's cool, but it's not cool. I've got sparks here as well. Oh my gosh, this is dangerous. I'm scared by this thing. So this seems to be pointing at the power supply, but I don't think there's anything wrong with the power supply. It's just the way it's built and it interacts with the average USB soldering iron. Let me have a quick conversation with Axel and I'll come back to you. That being said, well, the soldering iron should have some circuitry inside to recognize when there is a leakage to ground, and obviously a spark to ground is a leakage to ground. So there might be something wrong with my assembly. We might need to look into that. Bear with me. Alright, I've been doing a little bit of investigation on this problem, and I'd like to thank Axel, the AxxSolder community, and the EEV blog for making me understand what's going on here. So Axel ended up grinding some of his tips to see how they were made inside, and he came up with this. This is available on EEV blog, it's an old thread, and it shows you how the 245 tip is made inside. You need 2 things to make this soldering tip work: a heating element and a thermocouple. And you can clearly see the heating element and the thermocouples inside the 245 tip. A soldering station connects to a 245 soldering tip using 3 points. Red and blue are across the heating element, and the green is the shell of the tip, which is eventually connected to mains ground or protective earth. To energize the heating element, you're sending voltage between red and blue, and that will engage the heating element inside the tip. And to read the temperature back from the thermocouple, you're actually reading in between red, blue and green. But what is a thermocouple? A thermocouple is made of 2 different metals joined together. And for a curious effect, those 2 metals will generate a tiny amount of voltage when they're heated up. But in the end, those are 2 metals joined together, and when 2 metals are joined together, well, you have continuity between them. My multimeter here is in resistance mode, and I'm going to read the resistance between green and red, and as you can see, I'm reading a direct short. I switch the multimeter to millivolts. Let's see what happens when we warm up the tip. And you can see that now my thermocouple is reading 3 millivolts. It's very little, but that's enough for the electronics inside the soldering station for reading the temperature. Now that we understand how the 245 tip is working, well, I think that explains what was happening a moment ago when you saw sparks coming out from the soldering tip. Because we have a thermocouple in between the red and the green on a 245 soldering tip, well, the shell of a 245 tip is basically directly connected to the supply voltage, which is going to the heater. If you're using one of the recommended power supply with a floating output or salve, well, then it doesn't matter what kind of voltage you have on red and, of course, on green, because that voltage will not try to go to mains ground. You will be able to connect the green to the ground of the system without causing a short. But the U-green USB power supply I have on my desk is probably the very first USB power supply I've seen in my life where the ground of the output is connected to protective earth from mains. That means the power supply a PELV power supply where the output is not floating. So when I went to check for current leakage and I connected the tip to mains ground through my current meter, well, I effectively shorted the supply of the tip to ground through mains ground. I caused a dead short. It wasn't a little bit of a leakage of something. I was shorting 100% of the supply directly to ground. And that's why we had fireworks. We were shorting the supply to ground. Now, this doesn't seem to be the case with 210 tips, the smaller one from JBC. You can see from the drawing here that the internal connections are different. The shell of the tip is not directly connected to red, but it's going to red through the heater. So we have a little bit of a resistance, about 2 ohms, which is the resistance of the internal heater. So I would probably still have a good amount of leakage to mains ground using the 2110 tips, but not enough to cause sparks. So the bottom line of this whole story is that when you're using a 245 tip, well, the shell of the tip itself is directly connected to the supply voltage of the heating element. And that's why Axxel recommends using self power supplies with a floating output. But in light of what I've learned, I would say do not use PELV power supplies with the output reference to mains ground. If you do that and your board happens to be for whatever reason grounded to protective earth, well, you are shorting 24 volts to ground through your board. Now, the AxxSolder features a ground leakage detection, so in a normal situation it would warn the user that there is a leakage at the tip. Here I'm simulating a leakage. I'm connecting the earth connection to the negative of the supply voltage. And because we learned that the positive of the supply of the tip is directly connected to the shell of the tip itself, which is connected to the green cable, well, here I'm causing a direct short to ground, simulating a leakage to earth. And it works as expected, though that was actually footage I recorded for the just in case something happened, and something did happen. Well, apparently the leakage was a little bit too much, and the fuse has blown. I don't know how much you can see the fuse there, but it's clearly open. So I have one spare, only one. Let me replace it and hopefully that was it. Yes. And we are back in business. So yes, there is a protection, but apparently if the leakage to earth is too much, well, the fuse will blow and you'll have to replace it. So just bear that in mind. The PCB, the stencil, and even the 3D printed case were manufactured and supplied by PCBWay. This is by far the most complex project I built myself, and everything just worked. The quality of the PCB was just perfect, and you can see the quality of the 3D printed enclosure by yourself. The project is complex, but ordering from PCBWay is actually pretty simple. You will find a convenient zip file on the AxxSolder GitHub under fabrication. All you need to do is to download that file and upload it on PCBWay.com. The system will configure all the options for you, and all it's left to do is to choose the color of the PCB if you really want and select a postal service, and that's it. The PCBs will be delivered at your place. If you require the stencils, well, just make sure that you select the appropriate option. And a similar process applies to the 3D printed enclosure, it's just in a different section. Take a look at PCBWay.com using the affiliated link down below so you can also help the channel. And let me thank PCBWay for sponsoring my videos on my channels, because their help makes these videos possible. So thank you very much, PCBWay. Now let's continue with the AxxSolder. Let's do some power tests. Next, I'd like to try the coin test, or in this case, the copper plate test. This is a 3mm copper plate, and there's some solder on top. I'm going to melt the solder with the AxxSolder and with my JBC soldering station. I'm going to use the same tip for both tests. This is a genuine JBC soldering tip, and this should give you an idea what kind of thermal power the AxxSolder has. Will the AxxSolder be able to beat a genuine JBC soldering station? Let's test it. Before beginning, I'm making sure that the solder tip is clean for both tests. And I'm also making sure that the tips are reading exactly the same temperature, 350 degrees. The first thing I noticed is that the AxxSolder is very honest when it comes to reporting the actual temperature of the soldering tip. The moment I'm touching the copper plate, the temperature reported at the tip drops down to 290 degrees. That's a whole 60 degrees below the set temperature. And that is totally expected. It's a 3mm copper plate at room temperature. I've noticed that with most of the stations I work with, they tend not to report the actual temperature. I'd imagine that for the average user, seeing the temperature dropping to 290 degrees will spark some questions and concerns. But personally, I love the fact that the AxxSolder is not trying to lie to me. Even when the station is idle, I can see that the reported temperature jumps around the set temperature just a few degrees. And I believe that is totally expected, it's just that the average soldering station just doesn't report that. In any case, the AxxSolder and the JBC station, they end up absolutely even, so there is no doubt that the AxxSolder is doing a great job. Now let's get to some feedback. I've been using the AxxSolder extensively for a few weeks now in conjunction with my JBC soldering station. I've worked on hours and hours on different boards and the feedback is pretty positive, though at some point the AxxSolder went into earth leakage protection. And that really concerned me because that indicated that there was a leakage to ground, which told me that maybe there was a voltage on the tip that was trying to go to ground. I was a bit disappointed because it was immediately after I started working on my very first board with the AxxSolder, and I didn't want to damage that board, so I didn't really know what to do. However, I continued working on that board, it went totally well, and the next time I did a similar board, I had exactly the same problem at the beginning when I started working on that board. And then I understood what the problem was. I was desoldering a supercapacitor. Now, a supercapacitor like this is 1 farad in capacitance. It's massive compared to the average capacitor. It's designed to hold a charge for a long time. Now this capacitor leaves on the 3.3 volts on the board that I was doing. And I'm pretty confident that when I went to remove it using 2 soldering iron at the same time on both legs, probably there was still some voltage on it. This is still reading 1.5 volts, and the last time this got some power was probably a month ago. Now I went to remove the capacitor using both irons, touching both legs and pulling out the capacitor in one go. But both soldering tips are connected to protective earth, and that means that I'm effectively shorting the capacitor to itself. The moment I'm touching both legs with the tips, there will be a very small current flowing through one tip, through the protective earth on my desk here, and then back to the other soldering tip. Now the AxxSolder is able to sense that there is a current flowing to earth. That's considered to be an anomaly and that will immediately shut down the soldering iron. Let me show you here. So I can touch each one of the legs by themselves, nothing really happens. But the moment I touched both legs at the same time, there we go, grounding error, check connections and reboot. And this is intentional because from the AxxSolder perspective, well, there is a leakage to ground and something might get damaged. Now a supercapacitor like this has a very high ESR. That means that if you short it to itself like I've done a moment ago, well, there is very little current flowing. That is enough to trigger the leakage error, but it's not enough to blow the fuse as I did a moment ago. So everything still works totally fine. This is not an anomaly, it's intentional, and I feel this is a pretty good idea. Axel asked me whether you should add an option in the menu to disable this behavior, but I think this is not necessarily. It's like soldering on live circuit and it's never recommended. What do you think about it? Leave a comment down below if you feel that there should be an option in the menu to disable the leakage to earth warning. But anyways, the bottom line is no, there was nothing wrong with it, and I kept soldering on and everything was working totally fine. So my feedback is 100% positive. I am super happy with the AxxSolder, and I'm particularly impressed by the fact that this is using a switched mode power supply, but there is no current leakage at the tip. Absolutely impressive. Just bear in mind of what I said about USB power, that's a bit more tricky. It really depends on the quality of the USB power, not really the quality, but the type of the power supply, USB power supply that you're using. Besides that, I'm super happy with the AxxSolder and I'm super happy to recommend it. Well done, Axel, you've done something really good. Let me also thank all my viewers who took a few seconds to leave a comment on my previous video. It's been a very successful video, so thank you so much. I should have replied to everybody. Thank you for all the feedback, all the ideas. I'll always love reading your comments. So please leave comments down below, and hopefully you also enjoyed this video. And if you did, as usual, I'd appreciate a thumb up down below, and also consider subscribing to this channel and my second channel if you like this kind of things. Don't forget I'm on Facebook and on Patreon, the links are down below in the description. There is a free tier on Patreon, so no excuses, but if you don't want to support me on Patreon, well, maybe you can buy me a coffee, and the link is also down below in the description. If you don't want to buy me a coffee, that is totally fine, and I hope you enjoyed the video. Well, that's it for today. Thank you for watching. I wish you a great day and hope to see you again soon here on my channels for my next videos. Thank you very much, and goodbye. Bye bye.